This is Shantan Kumar, Assistant Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today topic is the mean value theorem. Under the mean value theorem, second one, that is the Lagrange's mean value theorem. In the last class, we discussed the mean value theorem, first theorem, that is the Rolle's theorem. And today, we are going to discuss that is the Lagrange's mean value theorem. Before going to discuss here also, we are going to discuss what are the conditions required to satisfy that is the Lagrange's mean value theorem, and what is the geometrical interpretation of the Lagrange's mean value theorem, and what are the conditions are required to satisfy the Lagrange's mean value theorem. And here, once again, we want to understand what is the meaning of the continuous function and what is the meaning of the derivative. The continuous function is nothing but without any disturbance when you are going to discuss the curve. That means when you are to draw the curve, you have the starting point to ending point without any break. That is the meaning of the continuous function. And according to when you are going to discuss the continuous function with the help of the limits, that RHS limit and LHS limit, that means the right hand side limits and again that left hand side limits, both the limits are satisfied. Then only the function is said to be, that is the limit is exist. That means the LHS limit, that is RHS limit, both are the same. And in other terminology, that condition is a differentiable, that is also the function is satisfied. The derivative exists while we are going to take the any points which is not infinity. That means which is a finite value in that particular, that is a certain limits. And one more thing, we want to understand what is the meaning of the closed interval a comma b and what is the meaning of open interval a comma b. The closed interval a comma b is nothing but including the points of the given function and that inside of the points also. That is the meaning of the closed interval. And the open interval is nothing but lies in between that certain the two limits only. It is not including the limits. Based upon the continuous and based upon the differentiable and including the open interval and closed interval. Now we are going to discuss that is the second mean value theorem, that is the Lagrange's mean value theorem. And here also, as it is that same the previous condition, but whereas the first method, that is a Rolle's theorem, that is f of a is equal to f of b is required to satisfy. But whereas we are going to discuss that here, the second, that is Lagrange's mean value theorem. The first condition is a continuous in the closed interval a comma b, and again the second condition, it is also that f is a differentiable in the a comma b, and again then there exists at least one point is c in between a comma b, such that there is f dash of c is equal to f of b minus f of a by b minus c. But while we are observing that first theorem, that is the Rolle's theorem, f of a is equal to f of b. But here, that f of a is equal to f of b is not required to satisfy, not required. Only here, f is a continuous in the closed interval a comma b, f is a differentiable in open interval a comma b, then there exists c belongs to a comma b, such that f dash of c is equal to f of b minus f of a by b minus c is a condition. If the three conditions are satisfied, then only the Lagrange's mean value theorem is satisfied. If any one of the condition is not satisfied, then the function is said to be, it is not applicable for the Lagrange's mean value theorem. Here, the geometrical interpretation of the Lagrange's mean value theorem, and here also, while we are going to discuss that f is a function a comma b, which is a real value, be a function satisfied the two conditions, that is the Lagrange's theorem. One is based upon the graph, it is a continuous function without any disturbing. For example, if you are going to consider a point to b without any break, that is a continuous with the curve is satisfied. And again here also the function is c is lies in between a comma b, and again moreover the curve y is equal to f of x, then there exists a unique curve. Therefore by the Lagrange's theorem there exists at least one point, there is a c belongs to a comma b, that is f dash of c is equal to, that is f of b minus f of a by b minus c is a condition. Next one, the mean value. It is also simply shortly we are defined that Lagrange's mean value theorem, that f be a function that satisfies by the following two hypotheses. F is a continuous on the closed interval a comma b, f is a differentiable on the open interval a comma b, then there exists c belongs to a comma b such that f dash of c is equal to, that is f of b minus f of a by b minus a. Other terminology, that is f of b minus f of a is equal to, that is f dash of c into, that is a b minus c. When we are going to observing according to the graph of this function, it is x-axis and also y-axis clearly. If we are going to draw the curve, that is a curve, that is a, if y is equal to f of x is a curve, that certain point a to b with without any disturbance. And again, the slope of the tangent, it is considered that is f dash of c, that is a c is lies in between a comma b is clearly, and a is equal to a, and again the slope of the curve, that is a chord of that f of b minus f of a by b minus a. And again, while we are going to observing, it is a tangent parallel to the chord of the function. Therefore, it is clearly understanding that function is a, what is it here? The graph of the function is clearly f is a continuous function and differentiable, and c is lies in between a comma b, that is with the help of the slope of the tangent. Next one, now we need to observe that one problem, whether the function is a Lagrange's mean value theorem or not. It is a function is a x cube minus x square minus 5x plus 3 in the interval 0 comma 4. Here the function is x cube minus x square minus 5x plus 3, and clearly while we are going to observe this function is a polynomial function. Therefore, according to that, every polynomial function is also continuous function. And second function, that f of x is a derivative, it is existed. Why? Because the derivative is a 3x square minus 2x minus 5, that is also finite value by taking all the values are 0 comma 4. And again, here we need to find out what is f dash of c is equal to f of b minus f of a by, that is a b minus a. Therefore, the f dash of c is equal to, just now I said, that is 3ac square minus 2c minus 5. Now we need to find out what is the f of b minus f of a by b minus a. Here a is equal to 0 and b is equal to 4 value. But here f of b minus f of a, that means f of 4 minus f of 0 by, that is a 4 minus 0. Therefore, that f of 4 minus f of 0 by 4. Now we are going to calculate what is f of 4 and f of 0. Therefore, f of 4 is nothing but in the given function, while we are going to replace the x is equal to 4, and the values are clearly, that's 4 cube minus 4 square minus 5 into 4 plus 3. The final solution is clearly, that is 31 only. And f of a, that f of a is equal to, at the point a is equal to 0. Therefore, f of 0 is equal to the value is 3. Therefore, that f of b minus f of a by b minus a, that is f of 4 minus f of 0 by, that is 4, is equal to, clearly the values are respective like 31 minus 3 by 4. The solution is, that is 7 is the value. Therefore, from the equation 1, what we are getting, that f dash of c minus f dash of c is equal to f of b minus f of a by b minus a. By equating from the equation is here, that is a 3c square minus 2c minus 5 is equal to, that is a 7. Therefore, that is a 3c square minus 2c minus 12 is equal to 0. Therefore, by solving this equation, by using the quadratic equation, with the help of that, there is ax square plus bx plus c is equal to 0. While we are going to consider, that is equation is ax square plus bx plus c is equal to 0. With the help of the equation, that is x is equal to, clearly we know that minus b plus or minus root of, that is a b square minus 4ac by, it is a 2a. By using this equation, while we are going to solving that, the points are clearly obtained that 1 plus or minus root of 37 by 3. Therefore, according to here, it is a 1 plus, by taking that 1 plus, that is a root of 37 by 3 only lies in between 0 comma 4 only. Why? Because if you are going to take the negative value, for example, it is 1 minus, that is a 1 minus root of 37 by, that is a 3 is equal to, it is a less than, that is a 0. Therefore, it is a not satisfied, that is a 0 comma 4 only. Therefore, here one of the value is lies in between, that is a 0 comma, that is a 4. Therefore, if the three conditions are satisfied, one is the f is a continuous function in the closed interval a comma b. Second one, f is a derivable function in the open interval a comma b, such that f dash of c is equal to, that is f of b minus f of a by b minus a, clearly which is satisfied, such that c belongs to a comma b. Second one, verify the Lagrange's mean value theorem. The function f of x is equal to, that is the function is log x in the interval 1 comma e. And here also, according to the first function, it is a continuous function. Why? Because the log function is almost a continuous function. Specifically, given the condition limits are given 1 comma e. Similarly, the function is a derivable. The derivative is also existed. Why? Because the log function is automatically, the derivative is 1 by, say, 1 by x, and here 1 by x is also satisfied, that is lies in between the given points of 1 comma e. Therefore, it is also applicable for the derivative, it is existed. Therefore, the Lagrange's mean value theorem, it is applicable for the first condition and second condition. Now we need to check out whether the condition C belongs to A, comma B. That is, with the help of the df dash of C is equal to f of B minus f of A by B minus A. Therefore, with the help of that one, the df dash of C is equal to, clearly the function is log x is equal to, that is a 1 by x only is equal to, that is f of B. That means here A is equal to 1 and B is equal to the value is E only. Therefore, f of B minus f of A is equal to, that is a log E minus, that is a log 1 by, that is a B minus A is equal to, that is a E minus 1. Automatically, that is a log E, that log E to the base E is nothing but the value is 1 only, minus log 1 is equal to the value is equal to 0. Since here, if you want a clarification, just you check it, it is a f of, that is A is equal to log, that is a 1, and f of B is equal to, that is a log, that is a E. Therefore, log E base E is equal to 1. Therefore, log 1 is equal to the value is a 0 only. Therefore, log B minus log A is nothing but 1 minus 0 by B minus A is equal to, that is E minus 1 only. Therefore, the complete is equal to 1 by E minus 1. And moreover, the f dash of x is equal to, that is clearly 1 by C only. Therefore, with the help of that 1 by E minus 1 is equal to 1 by C, by solving that equation, clearly that C is equal to, by equating the denominator, C is equal to E minus 1 only. And we know that value of E is equal to, that is 2.713. Therefore, the 2.713 is nothing but, it is almost, that is lies in between, that is 1 comma E only. Therefore, hence here the three conditions are satisfied. F is a continuous function in the closed interval 1 comma E, f is a differentiable function in the interval open interval 1 comma E, and f dash of C is equal, that is f of B minus f of A by B minus A. Then there exists C belongs to, it is also satisfied A comma B only. Therefore, it is also, the function is satisfied the Lagranges mean value theorem. Next one, it is if A is equal to, given an example of the function that is a continuous function minus 1 comma 1, and for which mean value theorem does not hold with the explanation. Here the function is considered, that is mod x, that mod x is a continuous function, that is minus 1 comma 1, but it is not applicable for the differentiable function. Why? Because in the first module, that is the first theorem, that is Rolle's theorem, same this type of the problem we discussed here previously, and based upon here is also mod x is which is does not exist because of it is a LHS limit and RHS limit it is not equal. Why? Because the LHS limit is a minus 1 and RHS limit is a 1 only. Therefore, it is does not exist the condition. Therefore, conclusion of this one, this problem it is not applicable for the Lagrange's mean value theorem. Here, the f of x equal to mod x, it is a continuous only, but it is a discontinuous, it is not applicable to the condition. Therefore, the function is not eligible for the Lagrange's mean value theorem, not holds. The next one, if A is less than B, then prove that B minus A by 1 plus B square is less than, that is tan inverse B minus tan inverse A less than B minus A by 1 plus A square. Using the Lagrange's mean value theorem, deduce that is pi by 4 plus 3 by 25 is less than tan inverse of 4 by 3 is less than pi by 4 plus 1 by 6. And second one, we need to show that there is a pi 5 pi plus 4 by 20 is less than tan inverse 2 is less than pi plus 2 by 4. First, we need to verify whether the function is satisfied the Lagrange's mean value or not. First of all, according to the function, it is considered that is tan x, tan inverse x. Why? Because while we are going to observing in this problem, clearly the function is based upon the, there is a tan inverse only, there is a tan inverse. Therefore, based upon the simple logic only, let us assume that is f of x is nothing but, you assume that is a tan inverse x because of the function is involving in terms of the tan inverse only. If it is